Hello everyone, this is Achinta Medi. This is the third video about chemical kinetic chapter. So in this video I'll discuss about second order reaction and some problems related to it. So first of all we have to know what is second order reaction. Second order reaction is that the reaction in which the rate of reaction depends on two concentration terms are called second order reaction. So let's write it. The reaction in which the rate depends on two concentration terms are called second order reaction. Okay, so that means there will be two reactant molecule. Okay, so but in this case there are two types of cases. You can see that means in some reaction that two reactant molecule will be same to each other, or in some cases the two reactant molecule are different. Okay, so we will discuss both cases. So first of all, case 1, in case 1 I will discuss about the both reactant are same. Okay, both reactants are same. Okay, so let's this A and A, these are reactants and it's giving a product. So when time is 0 at the initial state, there will be a amount reactant and there will be a 0 product. Okay, when time is t, it will be A minus X. That means X amount of reactant is converting to product. So we will write here X, and A minus X will remain here as a reactant, and A minus X remains as a reactant. So these are two different, not different reactant, same reactant, but this one one of the reactant and this is one of the reactant. So this two reactant, we are adding this two reactant and it will give you a product, and at time t X amount of product will be there. Okay, so rate will be proportional to, as it is second order reaction, so rate will be proportional to both reactant, concentration of both reactant, this one and this one. Okay, so we will write A square, or we can write A into A, or same you can write, and it will be A square. Okay, so then we can write rate as dx by dt is equal to K2. I am writing K2 because this is second order reaction, rate constant for second order reaction, so it is K2. And instead of A, I will write A minus X. It will be square. Okay, so we can write next dx by A minus X whole square is equal to K2 dt. So when we will integrate this equation, we will get dx A minus X square is equal to K2 dt. It will give you a minus x is equal to k2t plus c. So c is the integration constant. So at the initial state, that means t equal to 0, at that state x will be 0. That means when the initial state, when t is 0, there will be no product here. So we will write x is equal to 0. So from this equation, what we can write, this as t is 0, so it will be 0, and x is 0, so there will be only 1 by a will remain. Okay, so we can write c is equal to 1 by a. So when we will put this c value here in this equation, so we will get 1 by a minus x is equal to k2t plus 1 by a, and it will give you 1 by a minus x minus 1 by a is equal to k2t. Okay, so you can write this is the final equation for second order reaction. But if you simplify this, it will be like this: a minus x, here it will be x. Okay, so this is the final equation for second order reaction. Now if we discuss the half-life time for this second order reaction, so it will be t is equal to t half, and this, as it was a plus a to p, and at time t, that means t half, it will be a minus x and a minus x, and it will be x. So at when t half, that means half-life time of second order reaction, this a minus x part will be a by 2, will be equal to a by 2, and this part will be equal to a by 2. Then that means a minus x is equal to a by 2. Okay, so we will put this a minus x value in this equation. So we will get k2t half is equal to x, not in this equation, I will put in this equation, it will be a minus x. Instead of a minus x, we will write a by 2, and it will be a. So 2 will be here, 2 by a minus a is equal to 1 by a. Okay, so we can write t half is equal to a k 2. Okay, so this is the final equation of t half-life time for second order reaction. Next, if when we discuss about quarter life time for second order reaction, so as we know that these are at time t, a minus x will remain as a reactant, and x will be product. So when time is quarter lifetime, that means 1 by 4, that means at that time this a minus x will be equal to a by 4, and this a minus x will be equal to a by 4. So when we will put this value a minus x is equal to a by 4, we will get the quarter lifetime for second order reaction. So t will be t half 1 by 4. At that time a minus x will be a by 4. So as the general equation for second order reaction is k2 1 by a minus x minus 1 by a. So we will put here 1 by 4 minus a is equal to 4a minus a. So it will be 3 by a. So we can write T 1 by 4 is equal to 3 by A K2. So this is the quarter lifetime for second order reaction. And unit of rate constant for second order reaction is unit of K2. It will be, if we will put in the general equation, L n to the power n minus 1 mole 1 minus n second inverse. So we will put here 2. So it will be 2 L to the power 2 minus 1 mole 1 minus 2 second inverse. So it will be liter. Here it will be 1, 2 minus 1, 1, and mole, it will be inverse, and it will be second inverse. Okay, so this is the unit of rate constant for second order reaction. Now let's solve a problem. So in this question, the decomposition of gaseous acetaldehyde at T Kelvin follows second order kinetics. The half-life of this reaction is 400 seconds. When the initial pressure is 250 torr, what will be the rate constant and half-life if the initial pressure is 200 torr at the same temperature? So they have given that T half is this one, 400 second, and they are asking half-life for the second part. That means when initial pressure is, in this case half-life is even, in this case half-life so in this case, when half-life is 400 seconds, at that time initial pressure is 250 torr. Okay, and when initial pressure is 200 torr, they are asking what will be the half-life. Okay, what will be the half-life when initial pressure is 200 torr? Okay, first of all we have to evaluate the rate constant, and after that we will evaluate T half for initial pressure 200 torr. So as we know that for the equation of half-life, it will be K2 T half is equal to 1 by, as it is K2 T half is equal to 1 by A, but in this case they are not giving us the amount of reactant, they are giving us the initial pressure. So here it will be, instead of A it will be P naught, so it will be P naught. Okay, so it will be, we can write that K2 into T half is 400 and P is 1 by 250. So we can write K2 is equal to, this will come here, and 400 into 250, it will be 10 to the power 5. Okay, again now we are going to, as it is evaluated rate constants, next I will evaluate half-life. So for the second case, we can write the same equation, K2 T half is equal to P naught. So here we know that K2, that means this one, we know this part, and we know this part. That means P naught, initial pressure is given. Just we don't know the T half, and we are going to evaluate that T half. Okay, so it will be P naught into K2. So it will be P naught is given 200 into 10 to the power 5. So it will be 500 second. Okay, again let's discuss about kinetics of second order reaction, but in this case I'll discuss about second case in which both reactants are different from each other. So in this case, both reactants are different. So here it is A plus B is giving product P. A and B are different reactants. So when time is 0, it will be A and it will be B, and product will be 0. And when time is T, it will be A minus X and B minus X, and X amount of product will be there. So rate will be proportional to both reactants. So it is second order reaction. So concentration of A and concentration of B. So we can write this rate as dx by dt is equal to K2. So this is K2 because this is the second rate constant for second order reaction, and instead of A we will write A minus X, instead of B it will be B minus X. Okay, now we can write this two part, this this two part, I will bring this two part here, A minus X here and B minus X here, and here it will be K2 dt. Okay, so when we will integrate this equation, dx by A minus X B minus X is equal to K2 dt. Okay, so here so to integrate this equation we have to consider first of all this part 1 by this part A minus X and B minus X is equal to A by A minus X plus B minus X. We are just considering that, so let this part. Okay, then we can write 1 by X B minus X, and here if we sum this two part it will be A B minus X plus B A minus X. Okay, so we can say that this two part is same, so we can write the upper part, this A B minus X plus B A minus X will be equal to 1. Okay, as here it is A minus X B minus X a minus x, b minus x. So we can write a b minus x plus b a minus x will be equal to 1. Okay, so next we will write what, if we put x is equal to a, this x is equal to a, we will get what, so it will be b minus a. Next, if we put x is equal to b, then here it will be, when we will put x is equal to b, then b minus b, it will be 0. So this whole part will be 0. So only this part will be remain. So here it will be b a minus b is equal to 1. So we can write b is equal to 1 by a minus b. Okay, so it is also, we can write minus b minus a. Okay, now we are going to put this a and b value in this equation. Okay, so it will be a minus x b minus x is equal to, when we will put this value here it will be b minus a into a minus x. Next, when we will put b is equal to this one, so we will put here, so it will be minus b minus a, and it will be into b minus x. So we can take common as b minus a, 1 by b minus a we can take common. So here it will be a minus x minus b minus x. Okay, next we are going to put this value, this whole part, in the integration step. So here it was b minus a, that means where it was integration of dx by a minus x b minus x it was. So instead of that part, we will put this value here. Okay, so integration part will be like this: a minus x b minus x dx is equal to k2 t plus c. Okay, so here it will be, this is constant, so we will bring that outside, b minus a, and we will write separately these two things: dx by a minus x minus integration of dx by b minus x is equal to k2t plus c. Okay, so when we will integrate this, then it will give a 1 by a minus b minus a, sorry, and here it will be ln 1 by a minus x minus ln 1 by b minus x. It will be equal to k2t plus c. Okay, so we can write 1 by a b minus a, and this part, as it is ln, so we can write here it is in terms of minus, so we can write as a, we can a minus x divided by 1 by b minus x. It will be k2t plus c. b minus a ln this b minus x will come here and a minus x will come here. Okay, so it will be b minus x a minus x is equal to k2t plus c. Okay, so for time t is equal to 0, time t is equal to 0 at the initial stage, this part will be 0 and x will be 0. So we will get c is equal to 1 by b minus a ln b by a. Okay, so when we will put this c value in this equation, so we will get b minus a ln b minus x a minus x is equal to k2t plus b minus a ln b by a. So we will bring this part to here. So here we can write as common this 1 by b minus a, 1 by b minus a is common, so we will take this and ln b minus x by a minus x minus ln b by a. So here it will be k2t. So we can write 1 by b minus a and ln b minus x minus a minus x divided by b by a is equal to k2t. So we can write 1 by b minus a ln, here a minus x will come here, it will be a minus x, and b minus x will be here, and b will come up to here. No, sorry, the b will be here and a will be come here. A b is equal to k2t. Okay, so here it is, the general equation for second order reaction. K2t is equal to 1 by b minus a ln a b minus x b a minus x. Okay, so this is the general equation for second order reaction. Now let's solve a problem. So in this question they are saying that the rate constant for a second order reaction is 3.33 into 10 to the minus 2 dm cube moles inverse second inverse. If the initial concentration of the reactant is 0.05 mole dm cube inverse, calculate its half-life. So for this equation we have to know that the equation for half-life of second order reaction, and it is T half is equal to 1 by a k2. So here a is given here, a is here, this one initial concentration, so it is 0.05. okay, and here it is k2 is given here 3.33 into 10 to the minus 2. Okay, so it will give you 600 second or 10 minute. Okay, now let's solve another problem. So in this question you can see that there is a reaction here, and these are the concentration of A and B are given, and the rate is given here. These fours are rate, and this 4 and this 4 are concentration of A and B. So they are asking that what will be the order with respect to A, and next what will be the order with respect to B, and finally they are asking what will be the overall order of the reaction, and at the last they are asking calculate the rate constant. So first of all we have to know the rate of order of the reaction with respect to A. So for that you have to look at this. If when we compare 1 and 2, these two, this one and this one, when we compare these two, you can see that the concentration of A is same, 6.0 into 10 to the minus 3 and 6.0 into 10 to the minus 3. Okay, so concentration of A is same, but in case of B you can see that this one, these two, it is double. Okay, concentration of B in this case, in this two case, it is double. Okay, here it is 1, here it is 2, and in case of rate also you can see that the rate is also double. Okay, so you have to divide this 2 to this. Okay, so it will be 2 divided by 2, it will be 1. So as we increase the concentration of B double, that means when we double the concentration of B, the rate will double. Okay, so this B, that means this B tends indicating about B, and this A indicating about this concentration of A. Okay, so as concentration of A is constant, so there is no need to think about this, just think about this B. So here when you divide this 2 by 2, then you will get 1. So here it is B, this small b will be equal to 1. So small b will be equal to 1. Okay, in the next case you have to compare these two, 3 and 4. These two we are going to compare. So in this case you can see that the concentration of B is same in both this case, but in this case concentration of A is double. You can see that it is double, 2.0, here it is 4.0, but in this case the rate is 4 times increases. Okay, 4 times. So you have to divide this 4 by this 2. As it is constant, so there is nothing, no need to think about this B concentration, just think about this A concentration. Okay, so 4 divided by 2, 4 divided by 2, so here it will be 2. As B concentration of B is constant, so there is no need to write this B, just see about this A, as 4 divided by 2 will be equal to 2, so here it will be A will be equal to 2. Okay, this comes from here and this comes from here. Okay, so now I am going to write this thing in sentence. Comparing rows 1 and 2, we see that doubling the concentration of B keeping concentration of A constant, doubles the rate. Hence B will be equal to 1. Comparing rows 3 and 4, we find that doubling A, keeping B constant, increases the rate fourfold. So A will be equal to 2. So we can write second order with respect to A and first order with respect to B. So overall rate of the overall order of the reaction will be 1 plus 2 is equal to 3. So it is a third order reaction. So if we write the rate law expression will be rate law expression R will be equal to K, as the with respect to A it is 2, so it will be 2, and with respect to B it is 1, so we will write 1 here. Okay, so this is the rate law expression. So using this rate law expression we can calculate the rate constant. So K is equal to R A square B. So randomly we will select any one of the four condition, the data given in the question, any one of the data we will collect. Now we are considering the first one. So at the first one, the rate, you can see that the rate is 0.012. okay, and at that data, the first one, the A concentration of A is 6.0 into 10 to the power minus 3. So here it will be square. Okay, and here it is, the concentration of B is 1.0 into 10 to the power minus 3. Okay, so it, when you will calculate this one, so it will give you 3.3 into 10 to the power 5 dm cube mole mole inverse second inverse. Okay, now let's solve a problem. So in this question you can see that the hydrolysis of ester in presence of NaOH was followed, keeping their concentration same at 0.02 mole dm cube inverse. The specific rate constant at 35 degrees Celsius was found to be 5.55 dm cube mole inverse minute inverse. What proportion of ester will be hydrolyzed in 30 minutes? Next, also calculate the time for 30% decomposition of ester. So in this question you can see that there is not mentioned that what type of reaction it is. That means what type of order, first order, second order, zero order, what type of order it is. So it is not mentioned, but you can evaluate that what type of reaction it is. So from this unit of rate constant you can say that what type of order it is. So as you know that the general form of unit L n minus 1 mole 1 minus n second inverse. Okay, so here if you put 2 n equal to 2, it will be 2 minus 1 mole 1 minus 2 second inverse or minute inverse, whatever it is, just put the time here. Okay, then here it will be 2 L to the power 1 mole inverse second inverse. So you can write liter as dm cube. Okay, 1 liter is equal to 1 dm cube. Next, mole inverse second inverse or minute inverse. So you can see that this unit is same to here, dm cube mole inverse minute inverse, dm cube mole inverse minute inverse. So it is, you can say that this reaction is second order reaction. Okay, next, to calculate the what proportion of ester will be hydrolyzed in 30 minutes. So first of all we have to write K is equal to the general equation 1 by T 1 by T, it will be X A minus X. Okay, so here they have mentioned that, given that A is equal to, that means the initial concentration is 0.02 mole dm cube inverse, and rate constant is K is equal to 5.55 dm cube mole inverse minute inverse. Okay, so they are asking what proportion. So we will consider, let f fraction decompose in 30 minutes. Okay, so here it will be X. This X, what proportion will be? That means what proportion of product we obtain. Okay, so here it is X is equal to AF. That means there will be a fraction. So it will, if it is something like this, so you can write this 1 by X is 1 F. So this is a fraction, or y by x this fraction y by x is written as f. Okay, so k is equal to 1 by 30 we will put x instead of af, so it is af a minus af. Okay, so we can write 1 by 30 f. A will be cut off, a will be common here. Yeah, let's write this. A 1 minus f, so you can cut, so it will be f 30 a 1 minus f. Okay, now we will put the value of k and value of a. Here it is 5.55 is equal to 30 into 0.02 into 1 minus f. Okay, so here it is f, so f by 1 by af is equal to 5.55 into 30 into 0.02 is equal to 3.33. So f will be equal to 0.76, or you can say that this is 76%. Okay, so in this question, in a reaction when initial concentration doubles, the half-life is reduced to half. What is the order of the reaction? So for this question we have to know a general relation between half-life and initial concentration. So here it is, T half is proportional to a to the power n minus 1. Okay, so to remove this proportionation sign, we will put a constant here, k, any constant k a to the power n minus 1. Okay, so here it is, the condition is that a is twice a and t half is t half by 2. That means half-life will reduce to half. It is, and when initial concentration doubles, so when we will put this value in this equation, t half, or this equation, it will be t half by 2 is equal to k twice a whole to the power n minus 1. T half is equal to t half by 2 and a is equal to twice a. Okay, so we are putting this. Okay, then we can write this equation as k 2 to the power n minus 1 and a into a to the power n minus 1. So when we, and also we can write t half is equal to twice k to the power n minus 1 into a to the power n minus 1. So if we compare this equation and this equation, we will get what? Here it is t half, here it is t half. So this part, left hand side is same, so right hand side will be same. So we can write k a to the power n minus 1 is equal to twice k to the power n minus 1 into a to the power n minus 1. So here it will k will be cut off, and a to the power n minus 1, a to the n minus 1 will be cut off, and we can write 2 here, and 2 to the power n minus 1 we can write here. Okay, so 2 to the power n minus 1 is equal to 2. Okay, so when we will take log of this equation, it will give you log 2 to the power n minus 1 is equal to log 2. Okay, so this equation we can write n minus 1 log 2 is equal to log 2. This power n minus 1 will come here in front of this log 2. Okay, so it will be n minus 1 log 2 is equal to log 2. So log 2 will be cut off, and n minus 1 will be equal to 1. So n is equal to 2. So you can say that the order, what is the order of the reaction? Order of the reaction is 2. So in this question is second order reaction. It is given that second order reaction which initial concentration of its reactant as 0.5 mole dm-Q inverse. That means there will be two reactant A and B, and both have initial concentration what A is equal to B is equal to 0.5 mole dm-Q inverse. Okay, was carried out in presence of acid as catalyst at pH 4. Half-life of the reactant was found to be 16 minutes. So it is given that half-life T half is equal to 16 minutes. Okay, and pH means you can write H. For acid it is 10 to the power minus pH, and it is given that pH is equal to 4. So we will write 10 to the power minus 4. Okay, so it is in concentration, so it will be mole dm-Q inverse. Okay, so this is given. So for this question we have to know what is observed and true rate constant. Okay, observed and true rate constant. So here it is, rate is equal to K true H concentration of acid and concentration of B is equal to K observed concentration of A and concentration of B. So when it will be true rate constant, here it will be concentration of H, that means acid, concentration of H acid is included. But in case of observed rate constant, the concentration of rate constant doesn't depend, the rate doesn't depend upon the acid, or it is not written here. Okay, so it is K observed. So this is the general equation when K observed is equal to K true H, or concentration of acid. Okay, now for second order reaction, the half-life time equation is what? T half is equal to 1 by K observed into initial concentration. Initial concentration. So we will find out this K observed. Okay, so it will be K observed is equal to T half will be here. Okay, so T half is 60 and initial concentration is 0.5. So this will give you 0.033 is equal to, you can write 3.33 into 10 to the power minus 2 mole inverse dm cube minute inverse. Okay, so now we will calculate K true. Okay, so in this case K, you can see that this equation, so K true is will be equal to K observed divided by concentration of acid. Okay, so it will be K observed by concentration of acid. So it is 3.33 into 10 to the power minus 2 divided by concentration of acid. So here it is 10 to the power minus 4. Okay, so it will give you 3.33 into 10 to the power 10 square mole square inverse dm cube minute inverse. Okay, sorry, there is a mistake here. Here it is, if you see that the unit will be mole inverse dm cube minute inverse, and here it is mole dm cube inverse. Okay, so it will come here, so it will be dm cube, so it will be 6 mole square inverse dm to the power 6, and it will be minute inverse. Okay,
Thank you so much for watching this video. If you like it, please subscribe my channel and share with your friends.